He's gonna hit the.
We gotta
hit
take
the
the
fast.
He's going crazy. Run out the way. Oh my god. Oh! With the snow just on the brink of coming back this season, I wanted to analyze this video of my buddy Cooper wiping out on a sled last year. And I had two questions in mind that I wanted to analyze in this motion analysis project. Number one, how much force did Cooper experience in his back on that second impact where it kind of unfolds him? And two, what other real-world scenario could I relate this to? In order to analyze this scenario, I would break the problem up into two separate parts. Part one would be to determine Cooper's velocity at the bottom of the hill using Newton's second law, force equals mass times acceleration. And part two would be to determine the momentum lost based on the speed before and after the impact. The first step of this project was to collect some data. I went back to that hill and walked up and down the hill several times. Using a running app, it tracked my elevation gain as well as distance traveled. I then put these into a simple diagram where we now had a basis for our problem. In creating a free body diagram for the sled, we can see that there's an x component of the weight that causes acceleration in the sled. By dividing the net force in the x direction by mass, we get the acceleration. By multiplying the acceleration by the time it took for Cooper to get down the hill, we get the final velocity of around 10 meters per second. We were now ready to do a momentum analysis. To find the loss in momentum, I would subtract the initial momentum from the final. I estimated in the video that the final velocity was around 2.5 meters per second. This resulted in a momentum loss of 857 joules. Joules is defined as kilogram meters per second. So if we subtract joules by the duration of the impact, we would get the force of the impact, which we see was around 2,860 newtons. This is about the same force as a professional boxing knockout. Yikes.